Okay. So, first thing, teacher whinge. You obviously didn't do that bit of work I asked you to do. Alright? Whinge done, you'll know about it. What's going to happen? You're not going to know it when it comes to a test. I'm going to go through it now, for the second time. Right? Hopefully you'll get that information this time round. So, when we rationalise the denominator, so I'm going to take a step back, something we talked about last time, okay? So I'm going to take a step back to something like 5 over root 3, a simpler one, right? And I want to rationalise the denominator. What does rationalise the denominator mean? Hayley?
Take it out of its square root.
So get rid of the square root. Now, what we do to get rid of the square root of something like root 3, you have to multiply it by root 3. So we times by root 3, because that will give me 3. So root 3 times root 3 is 3. Okay? As with all fractions though, we have to do the same to the top. So the top becomes 5 root 3. And that's it. 5 does not simplify with the 3, so I have rationalised the denominator.
And that's your answer?
That's all. That's my answer. Okay? If I took it up to the next stage, so for instance if I add 2 plus root 3 over root 3, so now the numerator's got a bit more to it, we still have the same situation. How do I rationalise the denominator? I multiply by root 3, okay, which makes the denominator 3 again. But now I have to do the same to the top. So because I have 2 parts, I need to multiply the entire top bit. Okay, so now I have root 3 times 2 plus root 3. Now I can expand those brackets and simplify. Alright? Does that make sense? So when I expand then, root 3 times 2 is 2 root 3's. Root 3 times root 3 is 3. All over 3. Okay? Again, I can't cancel that 3 and that 3 because it needs to have a common factor and there isn't one. So I'm done. That's it. That's finished. Does that make sense?
If there was a common factor, what do you mean by that?
Yeah, if there was a common factor I could...
What do you mean by that?
Well, to be honest, if there was a common factor it would have appeared at this stage anyway for me to cancel out. But let's say, for instance, if I just have... So maybe you don't want to write this down. If I were to end up with 6 root 3 plus 3 over 3, right? There's a common factor of 3, so I could refactorise this and have it as 3 lots of 2 root 3 plus what? 1 all over 3, and then the 3 and the 3 would cancel to leave me just that. Right? But that's only, in this case, we didn't have any of that because that was a 2 and not a 6. That makes sense?
It's not a
If it was the other way and you didn't go the extra step, would you get it wrong?
Well, not get it wrong, but lose a mark for simplifying it, yeah. So, like you just said, if we had the 6 root 3 plus 3 over 3 and you left it like that, alright, you may risk losing one of the marks for the final simplified answer. But you have still rationalised the denominator. But a question like this might be rationalise the denominator and simplify. So just to run through that again, if this was the answer and not that, this would then factorise to 3 times 2 root 3 plus 1 all over 3, so that would cancel and just leave 2 root 3 plus 1. Okay? So both of those examples are where we have just a single part to the denominator. However, if I go back up to this one, this has actually got two parts to the denominator now, not two parts to the numerator. So we do have to do things a little bit differently. So I'm going to put brackets in there. Alright? And what I need to know is how do I rationalise the denominator when I've got two parts? And I gave you a tip at the end of the last time I saw you, which was to use what? The difference of two squares. Now if you remember, the difference of two squares was a plus b times a minus b leads to a squared minus b squared. Now the reason why that's useful is because if I square something with a root, I get rid of the root. So what do I want to do? Well, I want to multiply this by not 5 plus root 2, but 5 minus root 2, because I'm looking at these two. Okay? And I need to do the same to the top, 5 minus root 2. Alright? Make sense? It's very important that we have a plus and a minus. If I did plus and plus, like Ali sort of said to you, you foiled it out perfectly well, but we end up with still having a surd as part of the denominator. But if I do this, what do I end up with? Well, my denominator becomes, looking at this, if that's the a plus b and this is the a minus b, I end up with 5 squared minus root 2 squared.
Would it not be 2?
I haven't simplified it yet, but it will. We'll go through it. And then on the top, shall I expand this already? So 5 root 2 minus,
the same as the bottom.
what's root 2 times root 2? 2. So I get 5 minus 2.
What? Wait, why did you do that?
I've not done the bottom yet.
I know, but shouldn't you write it in the other form then?
What other form?
So like root 2 squared. And
But no, the top one is not the difference of two squares. This doesn't have a plus something next to it.
Okay.
The top is just an expand one term over a bracket, yeah? It's just the denominator is the difference of two squares. So I'm looking at, you know, this whole thing there. That's where I'm using this thing.
Wait, is
The top I'm not.
is that other green one your answer from like the next
It's not finished yet, is it?
But it's like the next step.
So this, if I expand that, I get this, my numerator. If I do the difference of two squares, I get this one. So now, I move on and I get 5 root 2 minus 2 all over. Well, that is 25 minus 2. So I end up with 23. Now, because this is one I've taken from a book and they've written it very nicely, you know 23 is a prime number, therefore it's not likely to simplify with anything on the top. So we can kind of know that we stop at that point. Okay? So that's it. That's my answer.
Wait, so that one there with the line, is that a numerator or a denominator, or is that just separating two answers?
What?
The one above where you're writing right now? Okay,
So this is it.
No, yeah, I get that. But the one above it,
Yeah?
is that line
That was a
separating the
working
numerator
step.
and the denominator,
Yes.
or is it two separate ones?
No, that's this bit is going there and this bit is going
Okay, so it's like a fraction.
Together
Yeah.
equals the 5 plus 3.
Okay, makes sense?
But then we still have
Alright.
that different.
I'm going to give you another one of those
That equals that.
instead of looking at this one yet.
With the fraction.
Alright?
So then
So,
can you upload this one to? Yeah.
I'm videoing it, it's always uploaded, so feel free to go and... right, so I'll give you another one. So I've got root 2 minus 2 all over 3 minus root 2. So, can you please rationalise this denominator?
But which one do you take?
Yeah,
Do you take the bottom one?
Rationalise the denominator. So, my focus is on the denominator, yes. Right, I just wanted, before I start this, so a number of you have got the right answer, a number of you sort of did the right things but made a couple of errors with negative numbers or expanding brackets or that kind of thing, but that's just practice. But I just wanted to explain to you the whole why are we rationalising the denominator, okay? Well, the reason is because when we do a division, which number is the easiest to divide something by?
2.
Apart from 1 is 2, yeah. Because you just split whatever in half, and it's quite an easy thing to do. What's the next easy number to divide by?
5.
5.
Can't divide by 0.
Okay, 10's really easy.
10's really easy to divide by. Give me a number that's really hard to divide by. 7, 67, so, right? 7, sorry, 3 as well, actually. That's because they will give you decimal answers. Now 2, 2 will give you decimal answers, but it's an easy one to work out. Now when I do a division, it's nice to have a nice denominator when you do division as a fraction. Now we've got a surd as part of, we've got an irrational number as part of our fraction in a denominator. And what that means is we've got to try and divide by an irrational number. Now an irrational number is a number that goes on forever, no? Right? Therefore, how do you divide by a number that you can't even write? Decimal goes on forever. So how do you divide by it? You have to put it in your calculator as root 2. So this is where it comes from, the whole rationalise the denominator. Make it a number that's easier to divide by. That's why we're doing it. That's why we rationalise the denominator and not rationalise the numerator. Because the denominator, the divisor bit, is the important one. So, just to go through it then, I think on the whole people got the idea. My tip, put your brackets in, top and bottom. The has to be multiplied by, the denominator has to be multiplied the same thing, but 3 plus root 2. Okay, you have to do the opposite. Right? Therefore, we have to do the same thing to the top, otherwise we change the value of the fraction. We then have the denominator becomes 3 squared minus, regardless of whatever it was before, root 2 squared, got to be the minus. So I'm just going to do that bit first. So my next stage would be 9 minus 2 makes 7. So my denominator should be 7. Go back up, do the top, FOIL it. So I've got 3 times root 2. Okay. Root 2 times root 2 is 2 plus 2. Minus 2 times 3 is minus 6. And minus 2 times plus root 2 is minus 2 root 2. So collecting like terms, I have 3 root 2's minus 2 root 2's gives me 1 root 2. And plus 2 minus 6 is minus 4. Okay?
I got that.
Okay?
Is it okay if we didn't differently than that?
Yep. Whatever method you have, as long as you're getting the right answer.
Is it okay if I put -4?
Yep. Negative 4 plus root 2 is probably the way it will get written, actually. Alright? Happy with that? You need to practice, because we're done with that now. That will be in your test. Ones like that. Right, I am now wanting to talk about this stuff. quadratics again, please. Alright? Now, what we have to be able to do is form and solve equations, alright, that will end up being quadratic equations, and that tends to come from questions involving shape, area and perimeter, mainly area. Do you know already why you think it's mainly area where a quadratic ends up coming from?
Because you have to multiply numbers to get areas.
Exactly. So when you area of a rectangle, for instance, you're multiplying two things together, and if we have two unknowns that we call x, when you multiply them, you're going to end up with x times x, which gives you the x squared. Okay? So, these type of questions. So, this, by the way, is in the old GCSE stuff, but you can see how the levels change. So, a B grade question, so for us now, what would that be, a 7 or something, would just be a simple 2x, 3x, 150, right? Grade A, it goes up to a binomial, so we've got an x plus 5, okay, multiplied by x plus 3, and then the A star question would be combined stuff.
Wait, so you choose what grade you want to achieve?
Guys, we can all do A of grade A.
Right.
Yeah, we can all do grade.
Now, so what I'm showing you the different. By the way, sorry, some of you are having your own little conversations, and your voice. I know you might not think anyone else can hear you, but it's a little drone in the back of my head. I can't hear what you're saying, but I can hear the buzz. So, if you want to talk with us about the question, great. Otherwise, just cut it until I'm finished. So, it's not about you getting to choose, it's about, depending on where they choose to put this level of question, so in an exam, sometimes quadratic equations will be there, well, we'll put a B level question in, or for you it will be a 7 question in, alright? Therefore, our level 9 question will not be quadratics, it will be vectors, or something like that, alright? The following year, or the previous year, it might have been the quadratics were the 9, and they give you an easier vector question. So that's why we have to do a full range from easy to hard of these type of questions. Okay? Just in case, because they will, you never know. I can't say to you the quadratics question will always be this hard, because they might give you an easier one. So, you'll notice there, for here, for instance, it's a show that question. It's a show that question. And most of them are. Alright? Now, what I would like you to do, so I haven't printed this off, but you can write it down. Shall we have a go? Shall I go through this one with you, or do you not need me to?
No, I don't understand.
Okay. So, for this one, maybe you'd like to draw the diagram for yourself in your book, so we've got your notes.
What's this called again? Sorry, quadratic.
So, quadratic equations, forming and solving quadratic, or solving problems with quadratics, if you like.
Is your call back to this? Can I please have an email?
Okay. Now, what's not in this question, but it is in the A star one, you see, quite often they'll say, here's a rectangle, or, one side is 2x, one side is 3x. The area of the rectangle is 150 square centimetres. They'll either say, find x straight away, or they'll say, show that something, something, something equals something, and you just have to know to use the area to get there. So what we'll do is we'll just find the equation for the area, and then we'll write the question that potentially might be there. Alright? So are we ready? So for instance, if I've got to find what x is going to be for 2x times 3x, because that's what we're doing. So the area is the information I'm given, so I know that 2x multiplied by 3x is going to give me 150. So that would be what? 6x squared.
Why would it be squared?
Because it's x times x, yeah? Equals 150. Now, quite often what they'll do is they'll guide you a little bit further and say, I would say, show that 6x squared minus 150. Actually, no, I wouldn't even do that. I'd go x squared minus, what we're going to do? 50, 20. X squared minus 25 equals 0. Okay? So if I said show that, and you'd go, how do I do that? Well, what we know is we're given a value for area, so we know to form our equation for area. But I've done that, so 6x squared minus 150. How do I get from 6x squared equals 150 to this?
Wait.
So minus 150 from both sides gives me 6x squared minus 150 equals 0. So that gives me the 0 bit. Alright. I'm still not quite there, so I have to divide by 6. So if I divide all by 6, I still get 0 here, but I get x squared minus 25.
Where did the 6 come from?
Why? I thought we were just trying to figure out why the area is 150.
No, well, I did say once we've got the equation, I'd write the show that
Oh,
question.
you added something extra.
I added it in, just like it might be. So in an exam, what they might do, for instance, it's not normally at this level, because it's a B grade or an A grade, they're not normally just going to solve that. So they'll go, show that, show this is true. So they're guiding you to show the working, so you have to do the working. Right? Then part B will be, tell me the dimensions of the rectangle. Solve for x. What are the dimensions of the rectangle? So if I ask for the dimensions, I'm saying, well, what is 2x? What is 3x? And to do that, I need to know what x is.
Yeah, shouldn't we finish the other one?
Yes, but
Plus or minus.
I would really like you to listen to yourself.
And then.
Alright? What I'm trying to do is break it up step by step, like it might be in an exam question. All you're doing is, oh, but can't we just go straight there? Well, yeah, I could. And then when you get a question in a test that is, do this, do this, do this, I know what's going to happen. You're going to come to me and say, you never taught us to do that. We have never seen a question like that in our lives. Yeah? So that's what I'm trying to do for you. I'm trying to get. So you will be asked to go through these steps. Now, this is the one I hear out of. I'm deaf in this ear, so you're on.
Really?
Then how'd you do it? Me too.
My grandma's like that.
Right. So we have done the first step. That what they're doing is they're making you show that you can do this. Then we just have to solve. So if we have to solve now for x, what do we do?
You do 150 divided by...
Why? I'm at x squared minus 25 equals 0.
Well, I was gonna... Okay. Oh, you plus 25 to 0.
Plus 25, so I've got x squared equals,
25.
which
and
means
then
x equals.
the square root of 5. Well, I was gonna do...
Well, in this case, we have x is 5 and minus 5, because it's a square root. Megan, are you with me? Yeah? But why don't I use the minus 5?
Because it won't be...
Haley?
Because it's a square rectangle.
Yeah, it's a rectangle. We're actually applying the solutions. Now we know that a quadratic has 2 solutions, but in this context, one of those solutions is not appropriate.
Well, what negative?
Say that again.
Yeah,
If it was negative, what would it look like?
Exactly.
Oh,
What would it look like?
It wouldn't look like
It wouldn't look like anything, would it? Now, sometimes, everyone, you've got to check, because sometimes the negative x, depending on what happens to it, might end up being positive dimension. So we'd have to check. But in this case, what are the dimensions of my rectangle?
2, 5, 10.
10 and 15.
Oh, cool.
Yeah?
I didn't know that.
Because I know that x is 5. Okay? I've solved. So therefore, 2 x's is 2 times 5, and this is 3 times 5.
Equals 100.
Okay? Just out of interest, because of what we were just doing, if I asked you to factorise x squared minus 25, what would you tell me? X plus 5, x minus 5. It's the difference of 2 squares again. Taylor?
You know when you did 6x squared subtract, where did you get the other 6 from? Like, why did you add it? I mean divide by it.
Because I've got 6x squared and I only wanted 1x squared.
So you tried to get rid of it?
So I divided by 6 both things, and 150 divided by 6 is 25. Right, now, second one, I'm going to let you do. Alright? Same principle, but it's going to be a bit harder, because this time you have binomial, so you have 2 parts. And therefore, when you multiply those together, you're going to end up with 2 brackets multiplied by each other. Okay? But you go through the same process. Now, when you get to the end, how do you how do you solve a quadratic?
We factorize.
You try to factorise, and if it doesn't factorise, you use the quadratic formula, you use your calculator for graphing it, whatever method you have. Right? Now be careful, because when you write this with the 2 brackets next to each other, you might go, oh, that's already factorised. However, how do you solve a quadratic? What does it need to equal?
0.
0. And this one, multiplied by this one, will equal what?
Not 0.
What?
26.
26. So you have to do a bit of rearrangement. So you have to expand, simplify to make equal 0, and then try and refactorise. Right. Over to you. If this one's too easy, as I think someone's already done, have a go at the A star one, where you've got to split it up first. Right, I'm recording, so just to bring people together, I think most of you now, almost all of you have got, you have x plus 5 multiplied by x plus 3 has to equal 26. Okay? Now we need equal 0. So, first step, we need to be able to subtract 26. But we haven't got anything to subtract 26 from yet. So we expand it. So we do x squared. Now if you remember the quick version, these two add to make the middle number. Therefore, plus 8x, and they multiply to make the 15. Alright, so I've got, I think everyone's fine with that, however you do it, quick, using full foil or whatever you want. So I'm at this stage, but I actually want equals 0, so I have to subtract the 26 from both sides. And I end up with x squared plus 8x minus 11.
Where do you get? Oh,
That's what I have so far.
Okay?
Oh, I messed up.
Now, this stage, we kind of know that it's not going to factorise, because 11 is a prime number, therefore it's only 1 times 11, and that is not going to add up to make 8. Alright? So we should go straight for whatever other method we have. Alright? So quadratic equation. So A is 1, B is 8, C is negative 11. So we've got, Megan, formula.
Minus b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, all over 2a. So then we've got minus 8 plus or minus the square root of 8 squared minus 4 times 1 times 11 all over 2 times 1.
Wait, would it be that negative 11 or?
Yes, it would be negative 11. Yeah.
Is it okay if we use the graph instead?
Yeah, you use the graph instead.
So when it asks us to work, like to show that, we
You would sketch the graph.
sketch graph?
Yeah.
It doesn't matter if it's like not accurate.
Yes.
So like I have to use a ruler to make.
No, I mean when I say not accurate, you would have to draw axes with a ruler, and you'd have to get the curve the right shape and crossing at roughly the right places. So if it crosses at -4 and -2, but it looks something completely different, if you've got one of them on the positive side.
Right, like.
Yeah, but it's got to be roughly right, and it does have to be a ruler axis and all that. Okay, so we're at this stage, so we've got -8 plus or minus the square root of 64 minus -44.
Plus.
So it's plus 44 all over 2. So I've got -8 plus or minus root 108 over 2.
You're going to do it 2 ways.
So I've got -8 plus or minus, well that's 108 is 36 times 3. So that would be 6 root 3.
How do you know
How do
that?
yeah.
Chiara's. I checked Chiara's.
I just put it in the calculator and it told me.
Yeah. All over 2. The 8 and the 6 cancel with the 2 to give me -4 plus or minus 3 root 3. Now there's 2 solutions there, but -4 plus 3 root 3 will be a positive answer, and -4 minus 3 root 3 would be a negative answer. So I only want the positive solution. Okay? Now if you went further and put that as a decimal, fine. I'm not at this stage, just because I've then got, this would be -4 plus 3 root 3 plus 5, which would be 1 plus 3 root 3. And this would be -4 plus 3 root 3 plus 3 gives me -1 plus 3 root 3. So they are my 2 dimensions. If I turn those into decimals, I'm right. Hayley.
Wait, can you slow down this?
Don't forget, if all you're worried about is I haven't finished my notes, they're on a video. Feel free to get them.
So for
Questions?
would it matter if I did 9 by 12?
Well, I wouldn't be simplifying enough, but no, I guess.
So what would
You
happen?
could simplify it further, couldn't you? That's all. Now, in this situation, Madison, in this situation, I want my dimensions of the rectangle, so it's not going to be as big an issue, the simplifying part. Right, all I'm going to say now is there are more complicated versions of shape and things like that. You've been given some worksheets with ones like that on them to practice.
Where?
Make sure you do.
The algebra.
You got your algebra booklet,
Do I have that?
yes? It was given out weeks ago, and I gave you a couple more sheets that were given out as well. It's all there.
Oh, this?
You have to do it. Pardon? Plus V, positive. Yeah.
What?